Okay, we're going to continue working on the S7 review packet on question number 6. Okay, consider events A and B. The probability of A is 2/5, B prime is 1/4. The union of A and B is 7/8. Write down the probability of B. So if we know that B prime is 1/4, we know the probability of B is going to have to be 3/4 because they both have to add up to 1. So the probability of B is 3/4. Okay, now find the intersection of AB. Now let's think about this for a second. The law of probability says what? It says the union of A and B is equal to the probability of A plus probability of B minus the intersection of the two. So I'm just going to write down the formula. Probability of A union B equals probability of A plus probability of B minus the intersection of A and B. Now we're trying to figure out the intersection, right? And we know the union. We know the probability of A is 2/5, and we know the probability of B is 3/4. So we're trying to solve for orange. So if we rearrange this, we can subtract the orange, we can add the orange on both sides and subtract the pink on both sides, and then we get the probability of A intersection B equals the probability of A plus the probability of B minus the probability of A union B. You may want to hit pause and think about that for a second. We added the orange one on both sides of the equation. We subtracted the pink one on both sides of the equation. Okay, so now we just substitute it in. So we end up with 2/5 plus 3/4 minus 7/8, and then we get a common denominator, which gives us 16 over 40 plus 30 over 40 minus 35 over 40. Add those all together and we get 11 out of 40. Okay. All right. Find the probability of A given B. So this is going to be the probability of the intersection of A and B divided by the probability of B. Okay, the intersection, I'm highlight in orange. Probability of B, we highlight in blue. So now we solve for this. This is equal to 11 out of 40, right? And the probability of B is 3/4. And so we've got a fraction divided by a fraction. So we can change this into multiplication if we take the reciprocal of the second fraction. So we have 11 over 40 times 4 over 3. Right, we took the reciprocal of this denominator fraction, and now we get 44 over 120. I'll accept that answer, but we can also simplify that to be 11 over 30, which is a fine answer as well. Okay, are A and B mutually exclusive? Justify your answer. Okay, so the answer, you can immediately say, if it's mutually exclusive, then the probability, let's look at our formula sheet. There's two things. Either the union is probability of A plus probability of B, or the intersection is 0. Well, we already know that the intersection of A and B is equal to the orange value, 11 over 40, right? And then so we can say, since 11 out of 40 is not equal to 0, it is not mutually exclusive. Now, another way I could have done it, an alternate way, I could have said, look, the probability of A union B equals probability of A plus the probability of B when it's mutually exclusive. We know the probability of A is 2/5. We know the probability of B is 3/4. We know the union, the union is 7/8. And we know that 7/8 is not equal to 2/5 plus 3/4. Okay, let's do the next one. Okay, show that the intersection of f of x is equal to 0.7. Okay, given this information. F is the number of customers that have a fish roll. S is the event that a customer has salad. N is the event the customer chooses neither a roll or a salad. So I'm going to draw a little picture here that should help. Okay, so fish, salad, and neither fish nor salad. So, and we know that that's 0.14. Okay, so these two here add up to 0.31. These two here add up to 0.62. Show that the intersection is this. So we know the, do we know the union? Aha. So if out here is 0.34, we know that the union is going to have to be 1 minus 0.14, because the union is these three spaces. The whole square is equal to 1. So 1 minus the 1.4, which is not having the fish roll or the salad, is going to give us what is the union. So we know that our union equals 0.86. Okay, so now I'm going to use our law of probability, which is the union of f of x is equal to the probability of fish plus the probability of salad minus the intersection. Right? So we're solving, we want to prove that the intersection is 0.7. I'm going to replace the union with 0.86. Probability of fish is 0.31 plus salad 0.62. Intersection, we don't know what this is. Okay, So if I add 3.1 to 0.16, we end up with 0.86 equals 0.93 minus that intersection here. So if I subtract that on both sides, we're going to end up with P probability of F intersection S equals 0.07. Okay. Okay. Given that the customer chooses salad, find the probability the customer will also choose fish. Okay. So we know the intersection here is 0.7 or 0.07. Okay. So I know that's 0.07. So given that the customer chooses salad, find the probability that the customer also chooses fish. Okay, so this is equal to the intersection of fish and salad divided by the probability of salad. Okay, given that the customer chooses salad, that's my denominator, find the probability that the customer also chooses fish. Okay, so we got my numerator, which is the intersection of the two, denominator, which is choosing salad. Okay, we know this intersection is 0.7. Even if we didn't know how to do question A, we still know the intersection is 0.07 because they told you. And the probability of S, you know, is 0.62. Okay, so you can simplify that and you should get 0.113, three significant figures with your calculator. Are F and S independent events? So in order to be independent, you know that the intersection of the two should be equal to the probability of F times the probability of S. So the probability of F, they told you, is 0.31. The probability of S is 0.62. Multiply those together and you get 0.1922, which is not equal to the intersection, which you know is 0.07, which we know from here. So since these are not equal, you can say it's not independent. You may want to hit pause and take some notes. Okay, this one here, we chose not to do it. It requires a quadratic. So I can do that in a separate video. Okay, question number 8. In a class of 40 students, in a class, 40 students take chemistry only, 30 take physics only, 20 take both, and 60 take neither. Okay, so first of all, 60 take neither. There's 60 people who don't take anything. Chemistry, physics, would find the information 20 take both, so I'm going to fill that in here. So now that I know 20 take both, 40 students take chemistry only. Okay, so this is going to have to be 40 students take chemistry only, and 30 take physics only. So chemistry only, I'm going to put a 40 there. Physics only, I'm going to put a 30 there. The word only is the key word here. Okay. So now I've got my Venn diagram. Okay. So the first question, find the probability that the student takes physics given that the student takes chemistry. So the probability given that they take chemistry, find the probability that the student takes physics given that they take chemistry. So this is going to be the probability of the intersection of physics and chemistry divided by the probability of chemistry. Okay, so first we need to figure out some information first. So the intersection of physics and chemistry is 20. Right? This intersection here is 20. Okay. The probability of taking chemistry is 40 and 20. So this simplifies to give me 20 over 60, or 1/3. Okay. Find the probability that the student takes physics given that the student does not take chemistry. Okay, so given that they don't take chemistry, I'm going to call that C prime. Find the probability that the student takes physics given that they don't take chemistry. Okay, so this is going to be the intersection of physics and not taking chemistry divided by the probability of not taking chemistry. Okay, not taking chemistry is 30 plus 60 in my denominator. Right, because chemistry is the blue circle, so not taking chemistry is 30 plus 60. Okay, the intersection of physics and not chemistry, physics and not in the blue circle, is 30. You might want to hit pause and think about that. Okay, so this simplifies to 30 over 90, which simplifies to 1/3. Okay, you might want to hit pause and think about this. State whether the event of taking chemistry and taking physics are mutually exclusive, independent, or neither. So, you know it's not mutually exclusive because the intersection of C and P is not equal to 0. So therefore it is not mutually exclusive. Right? Okay. Okay, let's see if they're independent. For independent, is the probability of the intersection, equal to the probability of C times the probability of P. Okay, the probability of C, let's find out what the total here is. 40 plus 20 plus 30 plus 60. The total here equals 150. So the probability of taking chemistry is 40 plus 20 over 150. And the probability of taking physics is 20 plus 30 over 150. And so that gives me 60 over 150 times 50 over 150, which simplifies to 2/5 times 1/3, which equals 2 over 15. And we already said, so this is the intersection of C and P, right? So let's figure out the probability of the intersection of C and P. The intersection here is 20, right? And the total here is 150, which is equal to 2 over 15. Is this value the same as down below? Yes, it is. So, therefore, it is independent. Okay, there you go. And that's it for that page.